Hello again. So we are doing problem solving for chapter 9. So these are the questions that we will be doing. If you want to try it first, this is the time you take a snapshot and try it yourself. If not, let's proceed to example 9.1. I'm going to repeat everything. I mean, we've done this before in class, but I'm still going to repeat it, okay? So how do I pause this? Okie dokie, so let's insert a page break there. Okay, so example 9.1, a particle performing a simple V equals to 2.75 meter per second and the period is 0.5 seconds. And I told you a particle that repeats itself is almost like a uniform circular motion where it starts from here, comes back to the same point. So the V is actually displacement. Sorry, not displacement, it's the distance. Where is my eraser? So that is the distance over time. That gives you velocity. And the distance to complete one cycle is actually 2 pi r, because that's your circumference equation. This is your circumference equation, right? And time is just the time taken to complete one cycle is just your t. And remember, we have discussed that for a uniform circular motion, your radius becomes your a. Your radius becomes your a, so it's 2 pi a over period. Gives you v. Okay, so we have the v, it's 2.75, and we want to know what is the a. So a is that, t is 0.5, so this gives me a of, what did I get? 0.22 meters. Okay, and then from our equation, calculate its frequency, amplitude, and maximum acceleration. So how do I calculate for the frequency? That's easy because we have t already, and we have an equation that relates t with frequency, which is f equals to 1 over t. So my frequency is just 1 over 0.5 seconds, gives me 2 hertz. Okay, so this particle has a frequency of 2 hertz. It has an amplitude of 0.22 meters. And its speed is 2.75. What about its maximum acceleration? We have talked about the maximum acceleration. Let's look at my slide again. Which one is it? I think it's earlier slides. So that is, which slide is that? Okay, it's this slide. So x max is a. The maximum for displacement is a, the maximum velocity is omega a, and the acceleration maximum is omega squared a. How do you get it? You get it from this equation. You get it from these 3 equations, but you have to make it positive, right? So this is the positive, it is at a, the positive here, it is at omega a. The maximum of acceleration here is, the maximum is omega squared a. Okay, so going back to that, so I learn balik. So now I get what? Acceleration, the maximum acceleration equation is omega squared a. I know what my omega squared a is because that's just 2 pi f, so that's easy. 2 pi f squared times a. So 2 pi f is 2. So I have to square the whole thing, and my a is 0.22, which gives me 34.74. And what is the unit for acceleration? It is meter per second squared. Salah unit, salah Okay, moving on to the next question. Kejap, let me insert page break. Okay, so a 1 kilogram, so 1.5 kilogram block vibrates according to the equation x equals to 0.38 cosine 6.5 t. It is a simple harmonic motion because this equation only has omega t, right? where x is in meters and t is in seconds. Determine its amplitude and its frequency. What is velocity and acceleration when it is at position x equals to 0.2 meters? So let's do that. Okay, so my mass is 1.5 kilogram and my equation is this guy. So if I were to compare it to a simple harmonic equation, the basic generic one, it should look like this, right? A cosine omega t. So now I just compare it. So this is x, right? A is 0.38, so cosine is a cosine, and omega is 6.5. Okay, so just comparing the generic equation to your question, I can already say that amplitude is 0.38 meters. Why is it in meters? Because x is in meters, so A should be in meters as well. And then determine its frequency. So we have omega. Omega is it's 6.5. And we know the relation between omega and frequency. It is omega equals to 2 pi f. And if my omega is 6.5, I can solve for f. So f is just 6.5 divided by 2 pi, which is equal to, what is it? 1.03 hertz. Okay? Right? So this is answer. Okay, let me erase that. Betulkan, dia cakap frekuensi dah, amplitude dah. What is the velocity and acceleration when t is at the position of x equals to 0.2? So when x equals to 0.2, what is t? What is t? What does t become? At what time does the displacement become 0.2? So that is the first question that you should think about. So how do you solve this equation to solve for t? Okay, so first of all, you need to change your calculator. Sorry, you don't have to change your calculator. I mean, you have to use your calculator in radians mode. Please, please, please. For this chapter, everything is in radians. So please use your radians mode for this. Okay, so what happens? 0.2 divided by 0.38. Inverse cosine of that will give me 6.5t. So t is just, use your calculator. Don't figure it out using your head, because I can't do that myself. What is the answer to this? It's 0.156 second. So what does that mean? At 0.156 second, displacement x is 0.2. Now, I want to know what is the velocity and acceleration at this particular time as well. So what do? I need to find my v equation, I need to find my a equation, and then I need to substitute my t so that I can find out what is my velocity and what is my acceleration. So the equation for v is, if you want to derive it, you can. If you want to just memorize it, that is the best, because you won't get it wrong. So that becomes, this is the generic equation. We know the amplitude is berapa tadi? The amplitude is this guy, right? 0.38 minus 0.38, and your omega is what? Your omega is 6.5. Then you have a sine, and then you have an omega t. And your t is, you already know what your t is that you want. So just substitute your t as 0.156 second. So if you use your calculator correctly, you should get your answer as let me try to write this. V should be minus 2.097. What is the unit for velocity? It should be meter per second when x is equal to 0.22. Sorry, when x is equal to 0.2 meters. Okay, so when x equals to 0.2 meters, your time when that happens is 0.56 seconds, which means that what happens to the velocity and acceleration at this time? This is what the question is asking you. Okay, the same thing for acceleration. You need to know what is the equation for that. It is omega squared a cosine omega t, right? Because I know it's negative omega squared x, so that is why I wrote it like this. X is a cosine omega t. Okay, that becomes a minus 6.5 squared, and my amplitude is 0.38. My cosine is just cosine. My omega is 6.5, and my t should be 0.156, right? If I don't want to write it like that, I can just say this is t, and I substitute that later. Okay, so substitute t, wrong arrow, substitute t as 0.156 seconds. So my acceleration should be, if I'm using my calculator correctly, which doesn't happen most of the time, 8.45 meter. What is the unit for acceleration? Meter per second squared. Get that right. Okay, so that is number 2. Remember, you have to use your calculator in radians for chapter 9. Okay, so let's continue with example 9.3. An object performs a simple harmonic motion and has a maximum acceleration of 8 pi. So A max is 8 pi meter per second squared, and maximum velocity of 1.6. So V max is 1.6 meter per second. What is the amplitude and its period? What is A and what is T? Sketch its displacement time graph. Okay, sketch displacement time graph. Okay, so these are the 3 things that they want, and I have A max and V max over here. So remember, we have seen the equation for A x max, which is A, and then we have seen the equation for a V max, which is omega A, and we have seen the equation for A max, which is omega squared A. Now I have A max and V max over here, so from here I can say omega A is equal to 1.6, and then I have omega squared A equals to 8 pi, right? And then I can say that omega A times omega, which is omega squared A, is 8 pi. And I know what my omega A is, which is 1.6. So I just substitute that here. 8 pi, so I can solve for my omega. So omega is 5 pi. Okay, so you can use your calculator. 8 divided by 1.6 is 5, so I'm just leaving that pi there. Okay, so now I want to find the period. I already know what my omega is, right? So omega is equal to 2 pi over t, and we know that omega is 5 pi, right? So what happens here, I can cancel out the pi, and I can say that my t is equal to 2 over 5, or just 0.4, or 0.4 seconds. Okay, and then I want to solve for my amplitude. I already solved the period. I want to solve for the amplitude. Since I already know what my omega is, okay, so previously we know that omega A is equal to 1.6. So from this, omega is 5 pi. Omega is 5 pi times with A equals to 1.6. So A is 0.102 meters. Okay, so I got that with the units. I got the period with the units. So now it wants me to sketch the YT graph. So YT graph is, sorry, this is an XT graph, but it just means displacement lah. Okay, so tersilap kat situ. So XT graph, because this guy punya equation is, it didn't say if it's an XT or YT. Okay, so it's just a displacement graph. So let's just assume that it's a cosine. Okay, so it's an XT graph. So my equation should be A cosine omega t, right? And my A is, I already figured that out, it is 0.102 cosine, and then I know what my omega is. It is, apa tadi? This guy, it's 5 pi times t. So I want to plot this equation now. So what happens? So let's see, I want to include, okay, so this starts from a 0. This is my time, and this is my displacement. Please label your axis. Kalau tak dapat markah. And then I'm going to use red for this. Okay, at time 0, from this equation, at time 0, cosine 0 is a 1. So at x times 0, 0.102. So that is 0.102. And this is at time 0. And then I want to divide this into, let's do this as t and this guy as 2t. This is 1 over 2t, and this is 3 over 2t. Kan? So one cycle or one wavelength is t. And then if I know the amplitude is positive 0.102, my negative amplitude should be negative 0.102. Kan? Okay. If I want to plot my cosine, it should be, kejap I'm very bad at plotting sebenarnya. So this should be where, okay, I'm just making marks because I'm just not good at it. Okay, alah kecil sangat lah. Okay, can I make this bigger? Yay, I can. Okay, so kalau saya nak plot a cosine, kan, let me use black. Okay, so dekat sini I should have a negative, kat sini I should have 0, kat sini pun 0. So it should look like macam tu lah lebih kurang. Okay, terus it will repeat itself. So okay, so kat sini korang buat elok-elok sebab ni susah ni pakai tablet ni. Dekat half a wavelength, it should be at negative A, and here at positive A. Okay, so it repeats itself here, it repeats itself here. So that is how you should label it. You can label the time like this, displacement like this, boleh. You can put in the actual value of t, which is 0.4 seconds. 0.4 second. You can label it 0.4, then 0.8 second, or you can just write t or 2t. Asalkan you define what is your t. And in this problem, we already defined our t to be 0.4. Kan? So you can write it as t. Okay? So how did I plot this graph from this equation? I used this equation. How did I get this equation? I got it from solving it. So I solved for A, and then I solved for omega. I got this equation. And then I figured out the amplitude, and I figured out how to plot it. Okay? This is the next question. Sekejap cari space. Okay, example 9.4. A spring with a spring constant of 19.6 Newton per meter. So that's a K equals to 19.6 Newton per meter is compressed by 5 centimeter. So dia compressed, which means that the displacement is 0.05 meter. A mass of 0.9 kg is attached to the spring and released from rest. So dia cakap tak if it's a vertical or a horizontal. No, it didn't say. So let's just say it's a horizontal, and then I compress it by delta X. Then I release it. Okay, I compress it and then I release it. Remember when I compress, okay, I need to make this bigger sebenarnya. Let me write that again. So spring. This is my equilibrium point. And then this is x equals to 0. X equals to 0.05. Okay, so this becomes delta x equals to 0.05. Kan, the displacement from the equilibrium is 0.05 meter. Okay, and this is at the left, so this is negative. This is the right, so this is the positive. 0, kejap, is having some difficulty. Okay, 0.05 meter. Tak ada meter ni, korang tahu je lah meter kan. I just want to show you the concept here. Okay, so I compress it. First I compress it, which means that I'm pushing it this way from the equilibrium. I compress it. Kan, saya tahan spring ni, and then I release it. At this point, my PE is the maximum. Does it move when I compress it? No, it doesn't. So my KE is 0. At this point, when it comes back to this point, my PE is a 0. And my KE is the maximum. And then my spring obviously loves to travel, so it wants to go to the other side as well. So my PE becomes maximum again, and my KE becomes 0 again. Because when it reaches the maximum displacement from the equilibrium, it instantaneously stops, which means that your KE at that point is 0. Okay, so this is what happens at these displacements. Okay, so now the question is asking you find the maximum elastic potential energy stored in the spring. So PE max, you know that. So PE max, you already know the equation. We've learned this. It is 1/2 KA squared. It comes from the 1/2 KX squared. But your maximum potential energy is when you reach your A. So when X equals to A is your maximum displacement, right? So you get your equation as PE max equals to 1/2 KA. So just substitute that. K is 19.6. Your maximum amplitude is this guy, right? 0.05 squared. Always change to SI units before you use it into your equation. So that it gives you 0.0245 joules. Okay, so now dia cakap find the maximum speed of the mass. And I told you the equation for a spring, the energy is always constant. Okay, so it can be E equals to P max. It can be E equals to KE max. It can be E equals to PE plus KE when they are not at their maximum. P plus KE. So if we know what our PE max is, we also know what is our KE max is, right? So PE max equals to KE max because E is constant. So PE max is 0.0. Okay, let me use a different color for that because this is not equation. So 0.0245 joules. And this is 1/2 mv max squared. I know what my mass is. It is 1/2. Mass is 0.9. And this guy is a Vmax that I don't know. 245. What's my Vmax? Vmax is equal to, what is it? 0.23. If you are using your calculator correctly, or if I'm using my calculator correctly, the answer should be 0.23 meter per second. So I like this type of question because you only deal with energy, and you know, I think it's more intuitive compared to simple harmonics. Okay, so next one. Okay, example 9.5. A 1.5 kilogram block at rest on a tabletop. Okay, the at rest on a tabletop is attached to an unstretched horizontal spring of spring constant. Let's use a different color for this. K equals to 19.6. Oh, it's the same. Okay, so dia cakap a 1.5 kilogram block is attached to a horizontal spring. Okay, so a horizontal force is applied to the object, causing the spring to stretch. So dia cakap ada force applied causing the spring to stretch. So this, if this is the equilibrium, or x equals to 0, this guy is stretching this way by 20 newtons. Let me put it next to it. 20 newtons. Kan? Causing the spring to stretch. Okay, so it stretches to some point. X equals to, we don't know. Okay? When released, the object performs a simple harmonic motion as expected, assuming the tabletop surface is frictionless. We don't have to care about friction. It determines the speed of the block when it is 0.9 millimeter. Misalnya, what is the speed? Kalau x equals to 0.0 millimeter, or what is it? Bagi 1000, 0.0009 meter. So dia tanya, what happens to the V when x is 0.0009? What is V at this x? So we know the equation for Vmax is apa itu? K over m squared A. And then we had equation V equals to K over m A squared minus x squared. Now we have K, we have m. Do we have A? Yes, we do. What is the A? The A is the maximum displacement that the spring can have, which is what we stretch it by, right? Now, how do we find A? Find A. Okay, so here, hint, I applied a 20 Newton stretch, right? So, spring has this equation, F equals to minus Kx. And I know what my K is. It's 19.6. And I applied some X, I don't know. But I know what the force is. It's 20 to the left. So my X is, my maximum displacement is 20 divided by 19.6, which gives me X of 1.02 meters. Okay, so if I'm applying 20 Newton to the left, my spring wants to, if I'm applying a force of 20 Newton, this is applied, so applied positive, saya lupa. F equals to Kx. So this is a positive, okay? So this guy becomes negative. So I'm applying F equals to Kx equals to 20 Newton. This is applied force. Okay, so what is the displacement when I apply this 20 Newton? What is the displacement of the spring from the equilibrium when I apply 20 Newtons to the left? So 20 newtons to the left, negative, and then plus, this equation is a plus, so K is your spring constant, 19.6, and then I can solve for my X, which is the displacement is negative 1.02, which means that it displaces by 1.02 to the left. So that is my X. Okay, so that is 1.02. How did I get it? I got it from this equation, from F applied for a spring. Okay. Okay, so it doesn't matter if you want to stretch it to the right or to the left, as long as you maintain the direction correctly. You maintain the direction betul-betul, then you will get the same answer. If you apply your F to the right, you will get your displacement to the right. Sama je. Okay. Okay, so now that I know what my X is, kan? So now my X, when I stretch by 20 Newton, that will be my maximum amplitude, maximum X, which is also my amplitude. Maximum displacement is equal to amplitude. So K is 19.6 and M is berapa tadi? 1.5. My A is, this is my maximum displacement that I can have because I'm applying 20 Newton squared. And then I want to know what is my V at a particular X, which is this guy over here. So 0.0009 squared. So my velocity at that point, okay, where is X equals to 0.09? It is kecil macam ni je. Maybe it's dia lepas equilibrium sikit je, sebab this whole thing is 1.02. This whole thing, the whole stretch of dia boleh putar-putar is from A to minus A, right? This is A, this is minus A. So kalau 0.0009 of this whole thing, it's like secuat je lah. Okay, so the answer is V equals to 3.69 meter per second. Okay, so if you were to ask me, Doktor, saya tak faham lah, X ni kat mana? So X is a positive, right? So this is 0. Kalau kat sini jadi negatif, kat sini jadi positive displacement. So 0.009 from this equilibrium point is, this is the point that you want to know. What is the V? So kat situ lah, terketuk pinggan. Okay, so I want to know what is the V at that particular point. Yeah, particular point yang secuat selepas equilibrium tu. So the V is, using this equation, I get the V as 3.6. The end. Not yet. Ada lagi soalan. 9.6. A 0.5 kilogram object is attached to a spring or spring constant 9. Okay, so K is, let me use a different color. I'm getting bored.
What's Halloween? What's Halloween?
Okay. No, I don't want to. Okay. Nah.
No.
So K is 90 Newton per meter. Betul tak? Okay. So dia cakap, and released from rest at T equals to 0 from position 0.25 from the equilibrium. So released from rest, T equals 0, position 0.25 from equilibrium. So if I were to draw my spring, this is my spring at equilibrium, X equals to 0, and then dia cakap displacement, position 0.25 meter. So 0.25 meter is here, which means that my box, kejap, let me use a different color for that. Ambilkan je lah, ada suara-suara tu. It's late. No, it's not late actually. So that is like that. So maksudnya saya stir. Okay. Okay. So this is when my kita release dia lah. This is time 0, V equals to 0. Okay, maksudnya kita stretch dia from equilibrium by 0.25. This will become your amplitude. Amplitude is 0.25. This is your time 0, V equals to 0. Lepas tu baru dia lepaskan. Dia lepaskan spring tu. what happens to the spring? It oscillates like a simple harmonic motion that it should be. Okay, so that is the situation. Find the equation that describes its x location. So x location ni displacement lah as a function of time. So xt equation. Draw its displacement time graph. Okay, dia suruh cari equation, lepas tu draw the graph. Okay, so you know the amplitude. Do we know the frequency? Do we know the omega? Okay, so let's just write a generic equation first. So x equals to a cosine omega t. At time 0, the x is 0.25. At time 0, x is 0.25 cosine 0 a. So a is 0.25. Okay. Okay, satisfied. Saja je nak buat padahal tahu dah a tu 0.25. Okay, lepas tu we know that v equals to how should we solve this? V equals to minus a sorry, we have the other equation. Okay, so we know that we can find the angular frequency by using k over m square root equation. K is probably 90 and the mass is 0.5, which gives me omega as 9.6. So omega is 13.42 radians per second. Okay. Okay, lepas tu now I have my A, I have my omega, so my equation is now complete. X equals to A cosine omega t is same as 0.25 cosine omega is 13.42 t. Okay, so kita tahu equation ni cosine. So we want to plot a cosine graph. So I have to draw my, kejap, boleh tak nak? Tak payah. So this is my graph. Okay, so time in seconds, and then x or displacement in meters. And I want to plot a cosine, and I know that my wavelength is, sorry, my period t is what? If omega is this, what is my t? T is 2 pi over t is equal to 2 pi over omega. So 2 pi divided by 13.42 will give me my t, which is 2 pi divided by 13.42, 0.47. Okay, so this is 0.47, 0.47 plus 2 times 2, 0.94. Okay, so that is my time just for one cycle, and this is for the other cycle. Lepas tu my A, it goes from negative A to A. So ini macam besar sini sikit, macam ni. Ini macam pendek sangat pula. Sekejap. Okay, so that is my A, negative A. So A is 0.25. My minus A is negative 0.25. Now I want to plot my cosine. Use a different color. Let me use green. Kat sini dia akan separuh, kat sini dia akan jadi negatif. Macam tu. Macam mana? Okay, this is how I try to plot my cosines. Macam tu. Okay, so again separuh 3/4. So dekat tengah ni dia akan jadi kosong. Saya gambar ni. Aduh, kalau ada graph paper kan senang. Sengit pula ni. Kunci. ABC lah budak gambar belakang ni. Okay. Lepas tu macam mana? Whoops. I should lalu sini ke bawah, lalu sini balik. Lepas tu kat sini dia kena sama dengan amplitude. Bawah ni kena sama dengan negative A. This is one cycle or equals to T. My second cycle. Okay, and then this is my second cycle. Okay, so 1 lambda, 2 lambda. You don't have to label the lambda. So I'm just showing to you. One cycle, 1 lambda, 1 T. So that is complete. Make sure you have your axis labeled. Make sure you have your A labeled. Make sure you have your T labeled. If you want to label as T, you should declare what is your T. So this becomes 2T. Okay? Next one. Example 9.7. A progressive wave equation is given as y equals to 12 sine 10 pi x pi over 3 t. So it's a wave, right? It's a wave equation. It's not an SHM. It's a wave equation. So you have y 12 sine 10 pi x minus pi over 3 t. If I were to write my generic equation, it would look like this. A sine, what is next to x is kx. It's minus omega t. If there is a minus, it means that it is moving to the right or moving forward. Okay, so your A is 12, your K is 10 pi, and your omega is pi over 3. Huh? Okay, so the calculate the speed of the wave. The speed equation is given by lambda f. So do we know what our lambda and f is? We can find it. So let's find that. Let's use pink. So k is equal to 2 pi over lambda. That's the equation. And omega is equal to 2 pi f. That is the equation. So if I want to use this equation to solve for my lambda, I would substitute 10 pi equals to 2 pi over lambda. So this gives me lambda as 2 pi over 10 pi. Cancel out. So that is 1 over 5 lambda. And then 2 pi f. I know what my omega is. It is pi over 3. And that is equal to 2 pi f. So this is divided by 2 pi equals to my f. Pi cancels out, so I get my frequency as 1 over 6 because 3 kali 2 6. 1 over 6 hertz. So speed is V is lambda f. So speed is 1 over 5, 1 over 6. What does that give me? 1 over 30. And 1 over 30 meter per second. Okay, boleh in fraction. Kalau tak fraction, it is 0.0333333333. Okay. So that is number A. Calculate the maximum speed of the particle. So max ni kan fikir doktor, equation V max equals to omega A tu kan dia untuk SHM. Yeah, but sebenarnya betul. This is for SHM, right? Kita dah simplify untuk SHM. So how do I get the velocity for this equation? Differentiate jugalah. So how do I differentiate this? So let me write it in generic form dulu because I like differentiating symbols rather than the value. Okay, so I want dy with d over dt, dy dt, because displacement over time gives me velocity. So this is my velocity. I have to differentiate equation y with respect to time. So A, I just leave it alone. Sine becomes cosine. Sine becomes cosine after differentiation. So this is kx minus omega t. and I have to differentiate the inside of this sine function, something that has to do with time. So this is the only term that has time in it. So differentiating omega t with respect to time gives me negative omega. So looking at this equation, what is the maximum velocity? Vmax is omega a. Sama je lah. Because the repetition in terms of time is the same. The only difference is x. So if I want to find v, the velocity, it is with respect to time, right? So Vmax is the same. So the answer is a omega. So darablah a omega. Okay. And example 9.8, a wave described by y equals to 0.0002 sine 0.5 x plus 628 t. As usual, I like to write the generic form first. So this is kx plus omega t. Determine its direction. This guy is a positive, which means that it is moving to the left. And what is the wavelength? Number 2, wavelength. So I have k, which is equal to 0.5. So k is 2 pi over lambda equals to 0.5. So lambda is equal to, I don't know, I haven't calculated that. 0.5, sorry, 2.2 pi divided by 0.5 will give me 4 pi or 12.57 meter. But lambda is wavelength is in meter. Okay, and then its speed. So 3. What is its speed? V is lambda f. Do I know what my f is? I should be. So let me find my f first. So omega is 2 pi f equals to 6 to 8. So f is 6 to 8 divided by 2 pi. 6 to 8 divided by 2 pi. So that is 99.95. 99.95 hertz. So now I can solve for my v. So this is v equals to 12.57, 99.95 over seconds, which gives me 12.57, and that is 1256. That's a lot. Betul ke jawapan ni? 36 meter per second. So that is number 3. Kejap 6 to 8 ni betul ke macam banyak sangat ni? Okay, 2 pi f 6 to 8. So frequency is 100 lebih kurang 100. Macam betul. So v is lambda, k over lambda is 0.5. 2 pi divided by 0.5 is 12.57. Betul. Okay, tak apalah, memang macam tu. Lepas tu plot its YT and YX graph. So your YT graph pahal. Yeah. Go. I need more space. Where do I do this? Abaikan je lah yang tu. I don't have the energy. Okay. So one is YT, so displacement Y, displacement in meter, and then T, time in seconds. Y, displacement in meter, and then this is time in second. T, time in second. And then I know that my lambda is 12.57. So T is here. This is, sorry, that is my lambda. It's 2 lambda. So 2T. Okay. So T is, I need to figure out what my T is. It is 1 divided by 999.95. 1 divided by 99.95, that is 0.01 seconds. And lambda is 12.57 meter. Oh, ni bukan time, ya Allah, tersilap. This is not time. What am I thinking? So this is distance. Let's label this as x, distance. Sebab yang tu buku tu dia macam tu, kita ikut je lah. Okay. So this is a sign equation. So by right, okay, sebelum tu kita kena label our A. This is our A. Our A is berapa? 0.002. And then we have negative 0.02. Okay, sama juga sini 0.002. Kita kurang. And then this guy becomes negative 0.002. Betul tak? 0.002. Okay, ada 2 kosong. Now let's use a different color for this. Purple. So it's a sign equation. Kejap. It's a sign equation. So it starts from a 0. Is it flipped? It's not flipped because it's a positive sign. So what happens? I need to label my tengah-tengah punya ni. Okay, so this like that. I like to make my dotted lines. Okay, walaupun buruk, tapi you guys must understand that I'm doing this on a tablet, not a ruler. It's given. Okay, so this is sign. It's not flipped. Oh. Macam tu So one cycle, then second cycle. Allahu Akbar. But you get the idea Tolong buat dalam bentuk yang sangat simetri, jangan ikut macam ni. But this is how you should silap. Whoops. Again. Entahlah budak tu. Biar je lah dia. Asalkan dia happy. Hello, please work out, please. Tak jadi. It's very hard. Okay, so that's one cycle. Second cycle. Oops, terlebih. Second cycle. Walaupun tak sama. Okay, so this is your YT graph. And this is your YX graph. From the same equation. Pretty cool. Alright, so that's it. Problem solving. Next is chapter 10. So that is it from me. Chapter 9. Thank you. Bye-bye.